Hello, students. Today, we are going to explore the fascinating relationship between electricity and magnetism.
So let's start with a quick revision. We know that a wire carrying a current behaves like a magnet. But here's a question for you to think about. What happens if we change the shape of that wire? Does it matter? That's the main puzzle we are going to solve today.
Here is our plan for today. We will start with the field around a straight wire, then learn the right-hand thumb rule. After that, we'll look at a circular loop, and then solenoids. And finally, we will have a summary with some very important exam tips.
Okay, so let's begin with the most fundamental shape, a long, straight wire that is carrying an electric current. Now, to really understand this, just imagine an experiment. Let's say we pass a straight wire through a piece of cardboard, and then we sprinkle some iron filings onto that cardboard. And here is what you will see. The iron filings, they form these perfect concentric circles. This beautifully shows us the shape of the magnetic field. These circles are the magnetic field lines. Now, a very crucial point here is that the strength of this field depends on two things. First, the amount of current. If you increase the current, the field gets stronger. Second, the distance from the wire. As you move away from the wire, the field becomes weaker.
So let's just pause and think for a moment. If you move a compass further and further away from the wire, what happens? Because the circles get bigger, the field gets weaker. So the deflection of the compass needle will decrease.
All right, so we know the shape of the field is circles, but which way are they pointing? For that, we use a very simple and very handy rule.
So this is the official rule. Now let's break it down into simple steps so that you can apply it very easily. Let's do a mental exercise. Imagine the current is flowing upwards, okay? Point your thumb up and see how your fingers curl around? That is an anti-clockwise direction. So that is the direction of the field. Simple.
Okay, so now let's take our straight wire and bend it into a circle. How does this change the magnetic field?
Just think of the loop as being made of many, many small straight pieces. Each little piece creates its own field. And if we use our right-hand thumb rule, we find that all these fields point in the exact same direction inside the loop. Now, towards the center of the loop, the field lines become straight and crowded together, and this tells us that the magnetic field is strongest and most uniform, right there at the center. So a logical question to ask next is, what happens if we don't have just one loop, but we have many loops, all wound together into a coil? Well, the answer is quite simple. The field from each turn just adds up. So for a coil with n turns, the magnetic field becomes n times stronger. Now let's look at a special type of coil, which is very, very important for practical applications. It is called the solenoid. So what is a solenoid? It is simply a long coil of wire shaped like a cylinder. You can imagine wrapping a wire very tightly around a pipe. That shape is a solenoid. Now, what's really interesting here is this comparison. A solenoid that is carrying a current, it behaves exactly like a bar magnet. It will have a north pole and a south pole. These parallel lines tell us something very important. They tell us that the magnetic field is the same at all points inside the solenoid. In other words, the field is uniform. Now, we can use this strong, uniform field to create a temporary magnet. We call this an electromagnet. We just place a soft iron core inside, and its magnetism can be turned on and off with the current. Okay, so to conclude, let us just calmly summarize the key points that you must remember for your exams. So, the crucial point is to remember these facts. And, very importantly, you must be able to draw the diagrams accurately for the straight wire, the loop, and the solenoid. You know, all of these complex ideas started from one simple observation by Hans Christian Ørsted. He saw a compass needle move near a wire. So remember, always keep observing and keep asking questions. Thank you.